Hello everyone, and welcome back to Master Math with Rami. In today's lecture, we will talk about trigonometric ratios. By the end of this lecture, students will be able to define a triangle, understand sine, cosine, and tangent. SOH-CAH-TOA. It is a simple way to remember trigonometric ratios, solve problems to find missing sides and angles in triangles. So grab your notebook, focus with me, and let us master this concept together. A triangle. A triangle is a shape with 3 sides and 3 corners. As we can see in here, it has 3 sides, it has 3 angles. The sum of the interior angles of any triangle is always 180 degrees. Triangles can be classified based on either angle measures or side length. In today's lecture, we will focus on the right triangle. A right triangle. It is a triangle that has one angle equal to 90 degrees, or known as a right triangle. Here is a triangle since it has 3 sides, 1, 2, 3 sides, or side A, B, and C. This angle is 90 degrees, 90 degrees. This angle, theta 1 and theta 2. So we have 3 sides and 3 angles, 1, 2, and the 90 degrees. It's very important to determine the hypotenuse, which is the longest side in the right triangle, and it is the opposite side to the 90 degrees angle. Trigonometric ratio. Trigonometric ratios, sine, cosine, and tan, etc., are relationships that connect angles and side lengths in a right triangle. Now, let us see how we can determine sine, cosine, and tan of theta. As shown in this figure, we have a right triangle because one angle is 90 degrees. Sine theta is always equals to the opposite side over the hypotenuse, The cosine theta equals adjacent side over the hypotenuse. And last thing, tan theta equals opposite side over the adjacent side. Many students get confused about which side is opposite and which is adjacent, and they often end up guessing. The first thing you must do is identify the angle you are working with, either this angle or this angle. In this case, we are dealing with this angle. Then you can determine the opposite and adjacent sides in the right triangle. Now, applying what we have just learned, sine theta equals to opposite side over the hypotenuse. Cosine theta equals to adjacent side over the hypotenuse. And tan theta equals to the opposite side over the adjacent side of the right triangle. There is a way to remember these relationships called SOH-CAH-TOA. So related to sine theta, which equals to the opposite side over the hypotenuse. CAH related to cosine theta, which equals to adjacent side over the hypotenuse of the right triangle. And the last thing, TOA, which equals to opposite side over the adjacent side of the theta. What is the length of side x? As shown in figure, we have a right triangle and the hypotenuse is 13 and theta is 42 degrees, and here is x, which is the missing side or the unknown side. We can't use Pythagorean theorem since we just know the hypotenuse, or I mean just one side of the triangle. And in order to apply Pythagorean theorem, we have at least to know two sides of this triangle. So we just go to the trigonometric ratio to find x. Equals to, always write equal. Here's theta, and x, it is the opposite. Then x, which is the opposite side of the theta. And also we know 13, which is the hypotenuse over the hypotenuse of the triangle. So what relationship connect opposite side and the hypotenuse? It's clear from here, which is the sine. Sine theta or sine 42 degrees equals to x over 13. Then x equal multiplication 13 sine 42 degrees, which equals to, using the calculator, 13 sine 42 degrees. And please make sure that you are using degrees in your calculator. Then it's almost 8.69, so it is 8.7 unit length. 8.7 centimeter. So this will be 8.7. Another question. What is the length of side x? We have a right triangle. Since one angle is equals to 90 degrees, and this is the hypotenuse of the triangle. Also, it's clear from the figure, we have theta equals to 37 degrees. We can't use Pythagorean theorem since we just have one known side. The hypotenuse is unknown, so we can't use Pythagorean theorem. We go to the trigonometric ratio in order to find x. Let's write equal. Here is theta, and x equals the opposite of 37, and there is 10, which is the adjacent of theta, opposite and adjacent, which is tan relationship. Then tan theta or 37 degrees equals to x over 10. Then x equals to 10 tan 37 degrees. That equals to 10 tan 37 degrees. That equals to 7.5 unit length, or if this one is centimeter, so this one is also centimeters. What is the length of side x? Here is x. It's clear from here, we have a right triangle and we have 9 unit length of this side, and theta is 60 degrees. We can't find x using Pythagorean theorem since we just know one side of the right triangle. So we can go through the trigonometric ratio. And right equal to, here is theta, and this is 9 adjacent, 9 right adjacent to theta, over x, which is the hypotenuse, over x, which is the hypotenuse. What relationship that connects adjacent and the hypotenuse? It is the cosine theta. Cosine theta, which is cosine 60 degrees. Then cross multiplication, x cosine 60 equals 9 times 1. Then x equals to 9 over cosine 60. Using the calculator, 9 divided by cosine 60. This equals to 18 unit length. Now there is a new type of questions. What is the measure of angle x? Now we want to find the missing angle, which is x in here. We have a right triangle, since this angle is 90 degrees. And we have this side length equals to 8 unit length. And the hypotenuse of this right triangle is 16. How can we find the angle? Here is theta. And this is 8, which is the opposite to theta. And we know that the hypotenuse. What's the relationship connect the opposite side and the hypotenuse? It's clear from here, sine theta. Then sine x equal opposite over hypotenuse, opposite length 8 over 16, sine theta, or I'm sorry, sine x equals to 1 over 2. Using the calculator, if you don't know, or before that, x, which is angle, equals to sine inverse of the half. Now we can go to the calculator. I'll show you how to use that. Sine inverse, it is like shift and sine 1 over 2, which equals to 30 degrees. So the missing angle here equals to 30 degrees. What is the measure of angle x? Another question. So we have a right triangle, and we have this side is 10, and the hypotenuse of this right triangle is 10 square root of 2, and this is the angle that we want to find. Since this is the angle we want to know, this is the adjacent and this is the hypotenuse. Okay, so what is the relationship that connect adjacent and the hypotenuse, which is the cosine theta? Cosine of x equals to adjacent over the hypotenuse. Adjacent equals to cosine x 10 over 10 square root of 2. Then cosine of x equals to, this can cancel this, which equals to 1 over square root of 2. Then x equals to cosine inverse 1 over square root of 2. Using the calculator, I'll show you how to find angle x. Cosine inverse, which equals to shift cosine 1 over the square root of 2, and that equals to 45 degrees. Write it in here, 45 degrees. So this angle is 45 degrees. Another question, what is the measure of angle x? Here is a right triangle with 9 centimeter this length and 12 centimeter of this side length. and this is x. Here it is opposite of x, and here is adjacent. So what is the relationship that connect opposite and adjacent? Here it is. It is the tan of x. Then tan of x, or theta, the angle, equals to opposite over the adjacent. Tan x equals to, the opposite is 9 and the adjacent is 12 centimeter. Then x equals to tan inverse 9 over 12. Then angle x equals to, using the calculator, shift tan inverse 9 over 12, which equals to 36.86, which is almost 36.9. 36.9 degrees. So angle x equals to 36.9 degrees. What is the measure of angle x? Please focus with me on this question. Looking at the figure, we note that we have two triangles, ADC and ACB. Here is angle x. In order to find x, we have to know at least one of those sides, this side or this side. It's clear that we have to find this side, since there is no enough information in order to find this side. So here is also 61 degree, and the opposite of it is 9 centimeter. And here is adjacent to 61. What is the opposite and the adjacent relationship? It is tan theta. First step, in order to solve this question, you can say that tan 61 degrees equals to opposite over adjacent, opposite BC over AC. What is BC? It is 9 centimeter over AC, what we are looking for, and this is tan 61 degrees. In order to find AC1, so cross multiplication, AC tan 61 degree equals 9, then the required AC equals 9 over tan 61 degree. Using the calculator, 9 over tan 61 degrees, then the length of AC equals 4.98. It is almost 5 centimeters. So here is 5 centimeters. Now, returning back to a triangle number, this one and this two, returning back to triangle 2, there is x, the angle that we want, and 5, which is opposite, and 7, which is the hypotenuse of the triangle 2. Since we know the opposite and the hypotenuse, we are talking about sine theta. So the second step, sine x equals opposite over hypotenuse, and the opposite equals AC over the hypotenuse AD side. AC equals to 5 over AD 7 centimeter. This is sine of x. Then x equals sine inverse 5 over 7. Then angle x equals to, using the calculator, shift sine inverse 5 over 7. Then x equals 45.58. So just add 1 to 5. and it will be 45.6 degrees. So the angle here is 45.6 degrees. Now here is a summary that talking about why do we use trigonometric ratios. First, for a right triangle, to find a missing side or a missing angle. So make sure that we are talking about a right triangle, just. If we are talking about sides, we can use a Pythagorean theorem, and at least we have to know two sides of this triangle or right triangle, so we can just find the missing side. Either it is the hypotenuse or the other two sides of the triangle. In the other way, trigonometric ratios, sine, cosine, and tan, we can use it to find the missing side or a missing angle using those relationships. Sine theta equal opposite side over the hypotenuse, cosine theta equals to adjacent over the hypotenuse, and tan theta equals to opposite side over the adjacent side of the right triangle. Again, a right triangle.